Hello everyone. So in this video, let us talk about a problem from the latest Codeforces round 769 problem named ABC. That is a problem. So I'll tell you in simple terms. It states that the students of school 179 has developed a unique algorithm which takes a binary string s as an input. Fine. However, they soon find out that if some substring t of s is a palindrome of length greater than 1, the algorithm will not work correctly. So, can the student somehow reorder the characters of S so that the algorithm will correctly work on that particular string? Now, you're given some string, you have to somehow find out that can you rearrange the elements of this whole string or the characters of the string, that is a binary string, so that there is no palindrome of length greater than or equal to 1. If there exists some string, like if you can somehow reorder it and convert to a string so that there is no palindrome of greater than 1 length, then the answer is true. Like you can do that, yes, or the answer is no, that you cannot do that. That's the whole problem. Now what you can directly see is that the constraints are pretty small, that is fine, but you can also see that from the inputs, I always encourage that see the inputs, you will find out some patterns around there. So for one, as you can see that for one there always exists the answer, because for length 1 you do not find out any palindrome of length greater than 1, so answer is correct. For 2, 1 0 is fine because this is already a non-palindrome. This is also a non-palindrome. But for this, as you can see that you can find out that this is a palindrome, that is 0 1 0. So if you find out, you have to just arrange them so that you cannot find out any palindrome. Now that's the whole problem. Now what you can directly observe is that for length 3, okay, let's write down all the particular possibilities of length 3. It can be like this: 0 0 0, or maybe let's say 1 1 0, or 0 1 0, or 1 1 0, or 1 0 1. All of that, there can be multiple possibilities. Like you can see that there are total of 8 possibilities. But what you can directly observe here is that like there are, like you can obviously 100% find out a palindrome of length greater than or equal to 2, because in this is a palindrome, in this is a palindrome, this is a complete palindrome, this is a complete palindrome, and this is a complete palindrome, and so on. So it means that going greater than 3 or equal to 3 also is not beneficial for us, because all of those cases, I somehow cannot rearrange the characters for the length 3 only. You can obviously 100% find out that there always exists a palindrome greater than or equal to 2. So you cannot do that actually. So now the case is boiled down to only length 1 or length 2. So length 1 and length 2. Now for length 1 it always exists, because either it is 0 or 1. The answer is obviously be correct, yes. For length 2, if the string is like this 1 1 or 0 0, then obviously it is a palindrome. But if it is like 0 1 or 0 or like 1 0, then it is not a palindrome. So then for that the answer is true, that this is not a palindrome, the answer is correct. For this the answer is false. For any length greater than or equal to 3, the answer is false, and any length of length equal to 1 is true. That's the overall all cases out there. So you can just directly move down to the actual example, or actually code for this. So you take the input of the string and the length. If the length is 2, then the string must be 0 1 or 1 0. Then all the answer is yes. Or else the other case for yes is that the total length of the string should be equal to 1. Then all the answer is yes. Else for all the other cases the answer is no. So that's the overall code. Nothing much too complicated out there. So thank you for watching this video till the end. I will see you next one. Till then, keep coding and bye.